Okay, thank you. I just would like to say that this work is kind of ongoing. We just have started with a student to work again on pipe. I work with many students in the past, but now we like to do like sort of integration, which is what I'm going to explain, and just to let it available on a GitHub. Okay. So basically, all the PetriNet space tool that we are taking into account to compare with pipe, and they are all free of charge, and they are all for free of charge for academic use. They all have a nice graphical user interface, and so they are, well, I'm sure you all know TimeNet, Great SPN, and Sharp. We are actually working on very deep comparison of them that I could not publish because it was not finished, but we hope we can write soon a journal publication in which we will have a very deep comparison of all these tools. Then going into pipe is open source, platform independent tool, and is implemented in Java. And as you will see, it has a full suite of analysis models. This tool started in about 2002, 2003 as a group project in the computing department at Imperial College. Then later on, I was there for a few years, so I started working on it also with William Nottenbelt and some students in there. And then we did a 2.5 version in 2007 already at the UIB. So from there on, there's been a few versions on both Imperial College and the University of the Balearic Islands where I work. So what I'm trying to do now with this student is to integrate all of these versions in one good version, okay, or trying to be good. So an overview of the GUI, is based on XML or PNML, following this PNML sort of standard. The editor has basically the normal features, cut, copy, paste, undo, redo, zoom, shortcuts to editor options, quick editor modes. Then as modeling power, of course, is a PetriNet, so we can have place, immediate and time transitions, arcs, inhibitor arcs, rate and marking parameters, capacity restriction of places, priorities for immediate transitions, different types of server semantics for time transitions. Then it allows two types of simulation, one which is like an animation mode or token game, so you can play around with the net and see what's going to happen. You can decide whether to choose to fire one or other transition. And also program simulation. So on the program simulation, you can get the traditional performance indexes. Then as modules, there are many different modules, some of them to provide structural analysis like minimal siphons and traps, place and transition invariants, the reusability and coverability graph that we will see an example because I think it's quite nice. Also, GSPN analysis with the traditional performance results, average number of tokens, utilization of places, throughput, token probability density. Then this is quite, I think, specific from pipe, so other tools don't have it, which is the import and export transformations. So the basic one is to graphical formats. This one, of course, the other tools also have it. But import and export transformations to other tools formats, like there is one for TimeNet format, and to other formalisms. So we can also import queuing network-based examples that are specified using the PMIF, the Performance Model Interchange format, that Connie Smith and myself worked on it quite a few years back already. Another a special thing of pipe, I think, is that it also has what is called an experimenter. An experimenter to define a set of model runs and the output desired from them. So the experimenter also complies with what is called the experiment schema extension specification, in which I also work with Connie and Ramon Pujané in this case. And it allows for editing an experiment or using an experiment that is already edited and doing a validation and execution of the experiment. And then the results can be shown on XML and also in an Excel file. So just a quick look of how the experiment will look. I will run the tool, but of course I won't have time to show everything. So that's why I just put a few print screens here of the different functionalities. So this will be how it looks, the experiment editor. It might be a bit difficult to understand at first. So we like to try to work on it a little bit more to make it more user-friendly. And finally, with this case study, I like to show the import from the PMIF. So this would allow to import a model that has been specified as a queuing network model using PMIF. And then we get and transform this model into a Petri net. So this is an example that comes from this Connie Smith article that has a CPU, a user thing, and a delay. Of course, and unfortunately, the model, when it appears first time, it doesn't look as nice as here. So this is something that we need to work on. And but the results are exactly the same as the ones that we get when solve the queuing network model. So just as conclusions, basically, again, this is kind of an ongoing work still, like the integration of all these features together, and with some more that come more from the Imperial side that I'm not taught today, but I like to also integrate those and to get the GitHub license. And we need to also improve many things like the other related tools comparison. For instance, the PMIF import that we have seen, just to allow that the drawing of the nets is nicer, allowing different scheduling policies and so forth. And just to finish, I like to show a little, let me see, demo of the tool with just something. I just need to change the sharing. Sorry, because this is the first time I use WebEx. We do here everything with Zoom, so now I'm lost with this.
Are you sharing the desktop, the full window, or just a single window? Because sometimes if you share the full desktop, it's easier.
Okay. So this time I share
because we see a blank screen now. A black screen now.
I think try to go to the top of your screen and typically.
Okay.
Yes,
now?
and then if you stop sharing. Okay, now it's coming.
Okay, perfect.
It's okay. If you can see the pipe, then it's fine.
Yes.
Okay. So Well, this is a basic Petri model, as you can see, produce zero consumer model. For instance, I like to show the reachability and coverability graph. It's quite funny, or it seems quite funny, but because you can play around and make it smaller and rotate it, you normally get to a view that you can easily understand. So the initial state is shown in here. I'll do it smaller. Okay. Then, as I said, you can like play around and do an animation mode and fire the transitions that you like to fire to see how it works. Then, of course, you have the different analysis modules. For example, this would be minimal siphons and traps, or the GSPN analysis. You get the steady state analysis results with the tangible states, average number of tokens, token probability density, and so forth. You also have a simulation one where you can decide about the parameters. I'm not going to run it now because the simulation, of course, it takes longer. And in here, you will have the experiment editor, which you have the options of open experimenter that's already there, or a new specifying a new experimenter. I'm not going to go through it because it's a little bit tedious, as I said, so I like to improve it a little bit more in order to have it user-friendly. And then the import and export. Sorry. Yeah, here they are. So for example, this would be the input from PMIF and the export to the different drawing formats, so different PNG, PostScript, and this is the TimeNet format. Okay, export to the TimeNet format.
Katy, sorry, I'm sorry to interrupt you, but we are already very late, so.
Okay. Okay, yeah, that's it. So I just like to show a little bit of everything, but it's enough. Thank you very much.
It's interesting, but I'm sorry we are already late. Thank you, Katy, for your presentation. Does anyone have a question for Catalina? I don't see questions in the chat and in Slack. Catalina, I have a question. What would you say is the distinctive feature of Pipe 2.7 that makes it very different from the other tools that you have mentioned also in your presentation? If you wanted to, just.
Yeah, I think what is mainly different is that these extra options that it gives related to the experimenter, which is nice to allow to the user to define experiment and to get the results also in a format that can be directly used, which is Excel. And also the import and export features that it has, because it allows to play with different tools. I mean, in this case, now we can play with the same model with TimeNet and Pipe, and also with different formalisms. So it's nice to be able to compare the solution of the models in these different tools or formalisms.
Okay.